Hello folks, welcome to EvolvNext and we are in the Python for Data Science module. Our today's topic of discussion is bivariate analysis. In this video, we are going to cover different types of bivariate analysis. That is numerical to numerical bivariate analysis, numerical to categorical bivariate analysis and categorical to categorical bivariate analysis. Moving further, we would see all these analysis drawing some plots, and according to the combination that we are using, whether be it numerical or numerical to numerical, categorical to categorical, or categorical to numerical, we will be using suitable plots and we will be drawing those. So typically we would see a scatter plot, then a line plot, box plot. We would also have a look at a stack bar plot, then a bar plot, and heat map, etc. All right, so let's jump in. The first line of code, as always, importing pandas, Seaborn libraries, then Matplotlib's pyplot module for drawing plots. Then here I have also imported one data set that is there in the sklearn library of Python. It is called as iris dataset, which we would be using for analysis. Along with iris, we would also load two different data sets, that is for flights, and one is a Titanic dataset. I've taken these datasets purposely to showcase various different plots that we can draw, as this data is more as per the suitability of data using this three data sets. So whichever plot suits or whichever data suits more as per the plot that we are going to discuss, that data set will be used. So to start with, I am importing flights data sets that is there in Seaborn library. That's the reason you would see sns.load dataset flights. This is the dataset that is there inbuilt in Seaborn library. See, I haven't uploaded anything over here in Colab. However, I'm using the dataset that are already there in Seaborn library or sklearn datasets or sklearn library. Okay. Now I have taken one variable airline and I've loaded that dataset named as flights. So let's see what is there in these datasets. If I do airline.head, I would see year, month, and passengers. So it shows that every year how many passengers were there in this airlines flights. All right. So to have a look at numerical to numerical analysis, what we will be doing is first we will be drawing a line plot, and following that we will draw a scatter plot. So let's draw a line plot to see that how many passengers year by year, was it an increase or a decrease. We want to see a trend that year by year did the passenger increase or decrease. So how we will plot, we'll be using the line plot, and we have function called as a line plot in SNS library, wherein you pass some variable on x-axis, some variable on y-axis, and mention the data set. Here the data set is airline. On x-axis we are giving year as a variable, and y-axis we are giving passengers as a variable. So let's see what is the output that we get. So here is a line plot that is drawn. That is, this line represents the increase in number of passengers from year 1949 to 1960, and you could see a continuous increase. So line plot is used whenever you want to see some trend across some time interval. All right, then moving ahead, let's have a look at scatter plot. To have a look at scatter plot, I have taken, as I mentioned earlier, this iris dataset. This iris dataset lies in sklearn library. I have already imported it, as I had shown in previous course, and here is how I load it. So there is a method called as load underscore iris, and I simply load the dataset from a sklearn library. Then I put it in a data frame, and then I would be using it. Now you would see what is there in the iris dataset with df.head. Here I could see there is a sepal length, sepal width, petal length, and a petal width. Petal width. Now, if I want to convert this data set and label it somehow, give a label on each row. Okay, so that's why I'm using iris.target. I have created created one column called as spaces, and I'm using this iris.target attribute to label it. So whatever labels will be created will be zeros, ones, and twos. So every row will have a label 0, 1, or 2. And now after that, what I'm doing, I'm mapping that label to a particular species name, that is Setosa, versicolor, and virginica. So you would see the data set later when we do a categorical analysis. I'm doing this on a purpose because I need this further for categorical analysis. First, let's draw the scatter plot as we discussed earlier, depending on sepal length and petal length. All right, so I'll just run this. getting some error over here. Let me check. Okay, the reason being I did not run the previous seal. How we are using species in numerical to numerical analysis as well. So look at this. The scatter plot would explain the analysis as per sepal length and petal length. We have also taken help of the species column that we created right now. However, you would see here that for versicolor and setosa, for versicolor and virginica, whenever the petal length increases, the sepal length also increases. So there is a direct correlation, or you may say positive correlation between the two species. However, here, if the petal length, we cannot comment the same regarding setosa as a species, because we would see only sepal length is increasing, there is no petal length that gets increased. So that's how you interpret the graphs. We are drawing graphs, we are drawing plots, whatever it is fine, but you have to come up with some insights. That's the reason you're drawing, right? So this is all about numerical to numerical bivariate analysis using scatter plot and a line plot. Okay, now moving ahead, numerical to categorical analysis. Here we would see a box plot and a bar plot. So let's have a look at box plot first. So I try to draw a species versus sepal length box plot. Okay, I have a method called as box plot in Seaborn library. That's the reason I use this syntax. Snx draws a box plot. X is equal to, on x-axis I keep species, on y-axis I keep sepal length, and I straight away plot it. So when I plot it, I'm able to see the sepal lengths as per the species. So species here is a categorical variable and sepal length here is a numerical variable. And we would easily be able to identify, depending on the sepal length, if and the range of the sepal length, what species it belongs to, and we'll be able to make out that okay, this is the range for virginica. This particular range, like here, if you count it, somewhere around 5.6 to 6.3, it's versicolor, and then 4 dot uh, 4 dot say 7, 4.7 or 4.8 to 5.2, it's setosa. So these are the insights that we can gain through this box plot. Same information can be made out from the bar plot as well. So you can draw a bar plot for categorical or to numerical analysis as well. All right. So these plots, whichever plots, the box plot or a bar plot I'm drawing, it doesn't suit for each and every analysis. Like depending on what analysis are you doing, whether you are doing numerical to numerical, whether you are doing categorical to numerical, and you have to choose the suitable plots. Now this is some guidance that I am giving. However, it's not always that you have to make it a hard and fast rule. Okay, if these analysis comes in, I have to use these plots. This is something that will come up with practice. So just have a look at the bar charts. Setosa, lesser sepal length, versicolor, a little bit more sepal length, and the bigger sepal length is virginica. So that's how we are able to see, observe the bar plots for different sepal lengths. Okay, then what we have is Titanic data sets. This is something that I've taken to do a categorical analysis. Again, we may use stack bar plot, heat map, or a group bar plot for doing the categorical analysis. So first, let's load the Titanic data set and have a look what is there inside. So this is the data set with regards to the famous incident when the Titanic ship got sunk, and it gives us the survived people, how many people survived, and what was the class of the passengers. That is 1, 3, and maybe there is one another class that is 2. In here it is not visible, but it's there. I've seen it. And then what is the sex of that particular passenger? Then what is the age of that particular passenger? And all these things they have uh, populated in this Titanic data set. Now let's do an analysis using a bar plot. So here we would try to observe, first understand the question, we will try to observe that which passenger class survived the most and which perished. So if we want the data of this, we will be focusing on survived column here and the passenger class column. This is also a categorical column. This is also a categorical column. In survived, we have only zeros and ones. One meaning the person survived, and 0 meaning the person perished in the disaster. All right. So let's draw a bar plot using count plot function in SNS library, and um, then moving ahead, we will see what all other plots can be drawn. So it's a simple bar plot that I have drawn. You would see here the passenger class. All right. So passenger class is in zeros and ones. So blue color is for 0, orange color is for 1. So you would see in passenger class 1, there are comparatively higher people, those survived. In passenger class 2, very less people survived, and passenger class 3, a little bit more survived, because class 3 may have number of people in class 3 together maybe more. And if you see the ones perished in the disaster, the number is high in class 3. So maybe this is economic class or something, and this is a first class as per the um, terminologies used by the Titanic themselves. All right. So these are the insights that you can make out, that most of the people who didn't survive belong to class 3. All right. So this is what categorical to categorical analysis, because we are checking on the survived category as well as the passenger class category. Then moving ahead, I would be using a cross tab function, because I need the total count of survived people and the people that perished, depending on the class, and want to arrange it in this manner. That's the reason I'm using this cross-tab function. And now I will be drawing a stack bar chart for the same. So if I plot a stack bar chart, look at this. Kind is equal to bar and stacked is equal to true. This parameter stacked is equal to true makes it a stack bar chart. All right. And whichever color I want to prefer, I can give it here. You would see red and green is been given. That's why it is displayed as red and green. Red and green. If I want to change some color over here, I can simply make it as blue, and then blue and green will be displayed. All right. And here is the output that you get. You would see blue color meaning survived people, then one meaning blue color, blue color is for 0, that is the people who did not survive the disaster, and 1 meaning people those survived in the disaster. So here is the same information we are displaying with stack bar chart. Instead of putting the bar chart one after another, we are putting it one above the other. So this is also one way where you can do the bivariate analysis. Then there is something called as heat map, which shows the correlation in this case between the people survived and a class. All right. So let's have a look at the heat map. Here you would see, look at this. Here you would see a heat map where on one axis there is a survived category, on another axis there is a passenger class category. They have used very dark red color to show the people not survived, and then they have used lighter color in between. So I mean, the lighter color will be in between. That's the reason you get a lighter color over here. That is the people survived and of passenger class 1. Okay. And you would see that much number of people who survived and belong to class 3 as well, because not all the people will be going for the uh, class 1. There may be number of people who went for class 3. So that's the reason you get this kind of figures. Forget about this plus 0 to e plus 0 to and all this. This is just because of the metrics that you have put in. So we have not standardized this yet, that we can definitely do. The thing to observe is that how the color scheme works here. And here the color scheme is not from darker to lighter or something, but they have a mixed one. That is, for the not survivor, they are going towards dark red color, and for the survival, they are going towards the blue color. So how the things are related, that they have shown over here. Okay. This is about the heat map. Then what is the grouped bar plot? So let's say we want to have a survival count by gender. Then how would you do it? We will take the sex variable, and we will also take the survived variable. This again is a categorical to categorical comparison. However, we are using a grouped bar plot in this case. So the same count plot we are using, and this is called as a group bar plot, wherein we can see by category that okay, in male category there were a lot of non-survivals, and in female category, there were a lot of survivals as compared to the male. So this is how you can take out the insights out of it, and you can do analysis on the basis of categorical to categorical data. Now, having said all this, these are not the only charts with respect to the different combinations of bivariate analysis. You may well use some other charts as well. However, we have just used the frequently uh, used we have seen the frequently used charts and try to do as much as bivariate analysis as possible. So I hope I was able to convey the bivariate analysis concept along with all the different various plots, and you were able to understand those. So thank you for watching my video, and I'll see you in the next video. Thank you.